Hello everyone, I hope you all are doing well. So in this video, I will go over Unit 6 Part 1 and it is about arrays. So far in the course, you've learned how to work with variables and constants. And if you remember, variables can only store one value at a given time. So for example, if I create a variable num, which is an integer, and it stores the value 2 initially, we know that in memory it is basically stored this way. It creates a small space for the variable, the name is assigned, and then the value is stored within the space. Now somewhere in your code, if you change the value of this variable to, let's say, 5, what happens in the memory is that the previous value is removed and then the new value is stored. So at a given time, you can only store one value in a variable. There are cases in programming where you would want to store multiple values of the same data type. A few examples could include maybe storing student IDs for a specific section or course, maybe storing the names of students or employees or whatever, storing their names, storing marks of a particular section or course, storing prices of specific products, so on and so forth. The only thing that you need to be careful about is that the data that you're trying to store should have the same data type. What that means is all the student IDs are actually numbers. There is no student ID that has a character. Let's say there's no student ID that has the letter A or M. It's all numbers, right? So in that case, we can create an array for it. But if some IDs were numbers and some were alphabets, then it would be difficult to create. You wouldn't be able to create an array for that. Here, the names are basically text or string, if you remember. So all of them are the same, right? Again, marks are numbers with decimal points, so you can use either double or float for this, and prices, again, you can use double or float. So the data type is basically should be the same. Now in Java, if you want to have a proper definition for an array is nothing but a named collection for storing values of the same data type. So you give this collection a name and you use it for storing values of the same data type, like I've just given examples about. Now, how does this look in memory? How can you visualize it? The concept is very similar to how we create strings or how strings are visualized. So for example, if I have string name is equal to my name, in the memory it is created like this. There's a big container, okay? The name that you assign here is basically assigned to the whole container, and this container is divided into sub-containers, or we call them indexes, right? So this is 0, 1, 2, 3, 4, 5, and then 6. So here my name would be stored in, so each character in my name is stored at a different index. So M, A, L, E, E, H, A. Okay, this is how strings work, and we know that you can get, if you want to get characters at specific indexes, you can do that by using name.char at, or if you want an index of a character, you can use dot index of a character. So there are many methods that you can use. The same concept is applied to an array. So in general, this is how an array would look like. For example, I want to store all the let's say I want to store student marks for a specific class or a specific section. Okay, what I can do is I can create a container, okay, which is the array basically, and give it a name. Let's call it marks in this case, and then divide this for the marks for each student to be stored. Okay, and then give it an index, so 0 1 2 3 4 5 6. And what I can do now is I can store numbers in each of these positions. So I can store, let's say, a mark of 80 here, 61 here, 35 here, 42.5 here, 100, 92, 73. Okay, so what is happening here is you're creating a container. Okay, that container has sub containers or sub block, it has blocks within it, and at each block you can store a value. Okay, now how would you write this in code? In code, because here we can see that one of the values is a decimal, meaning it has a decimal point, this whole array will use the data type double. Okay, double, and then the brackets, the square brackets, no space in the middle. You will write the data type first and then put two brackets, an opening square bracket and a closing square bracket. This signifies that it is an array. If you don't put this, it will just assume that this is basically a variable. So when you put the square brackets, the compiler knows, or the system knows, that okay, this is an array. Okay, this is the first part. Now after a space, you will give this array a name. So in this case, I've used the name marks, right? So I would write marks here is equal to new double brackets semicolon. Now, just like how we use the new operator for scanner for decimal format, for arrays, if you're creating an array, an empty array, you're supposed to use the new operator. So double square brackets, the name of the array equal to, and then the new operator, and the same thing that you wrote here needs to be written on the right side. But the only difference is now on this side, within the two brackets, you need to specify the size of the array. This is important. So you need to tell the compiler or the system that this array will have these many blocks or these many storage spaces. So in this case, we have 1. So this is considered 1, 2, 3, 4, 5, 6, 7. So in this case, I have 7. If I had let's say 20, then this number would be 20. So this is nothing but the size or the length of the array. This way is for creating an empty array, meaning when you write this line of code, it's going to create a storage space like this, but without any values. This is how it would look like initially. It is empty. Okay, no values are stored. This is one way of creating the array. The second way is you can assign the values directly. So here I can say double array marks equal to curly bracket, and then within the curly brackets, the values separated with comma. Okay. In this case, you do not need to use the new operator. You do not need to specify the size. The compiler will automatically calculate the size by taking all these values. And what happens on the back end is this part creates the space in the memory with all those divisions, and then this part takes each of the values and stores them in the correct place according to their order in this list here. Okay, now again, this way it it's basically the in when you write code, when you create an array this way, it's not empty. But when you use the new operator along with the size, it creates an empty array. That's the only difference. Now, how would you access or how would you use this array? That is the important part now. So let's say you have this is going to take a long time. Okay, so let's say you have an array of marks again. So double array marks is equal to 80, 71, 62.5, 100. Okay, in the memory we know it's going to look something like this. It will start the name will be given to the array here. It will start at 0, 1, 2, and then 3. Now, in order to access this array, we use two things. We use the name of the array, okay, and then we use something called the subscript, which is nothing but the square brackets along with the index in the middle. Okay, so for example, if I want to get the first the value at the first index, I'm going to write 0 because arrays start from 0. So if I want the first, sorry, okay, I made a mistake there. If I wanted to get the value stored at the 0 index, I can write 0 here. And if I use this statement to print, for example, if I write, I'm just going to write s out marks 0, this will print 80. Okay, if I use s out marks, again this is system.out.println, don't just write s out in NetBeans, it will not work. Marks 3, this will print for me 100. But if I try to write marks 4, now the index ends at 3. It starts from 0, then there is 1, 2, and 3. There's no 4. If you try to access an index that does not exist, the program will crash. Error. It will give you an error, and then it will crash. It will not give you an error, a compile time error or a syntax error. It will give you a runtime error, meaning it will crash the program when you try to run it. Now, and basically that error is also called index out of bounds. Okay, so this is how you access values that you store in an array. So one at a time you can access those values using the index or the subscript. This part is basically called array subscript. Okay, so now you can there are two things that you will notice in your lab questions. Either the questions use the word index, or they will use the word position or item. Okay, what is the difference? Index is when you count the array, when you start counting the array from 0. This is the natural counting of the array. So for example, this is 0, this is 1, 2, 3. Position or item is basically the human count, which means if I say first position, it is actually here, but the index is 0. So when you count as a human, you count from 1, 2, 3, 4, 5 onwards, right? So when the word position or item is used, you're supposed to you're supposed to count it um, like we normally count, but then figure out the index for it. So for example, if I want to print the first the item at the first position, if I want to print or let's say I want to print the first item in the array, the word item is human count, so you're going to count like a human and you're going to see, oh, the first item is this 80 and it is at the 0 index, so you're going to get it by writing 0. Okay, if it says get the value at the second position, so this is using human count, this is the first position and then this is the second position, so it is stored at index 1. What I'm trying to say is position, whatever number they give you in the position, using the word position, just subtract 1 from it to get the actual index of that element. Okay, so for example, if it was the first position, if it was the first position, so 1 minus 1 is 0. If it was the second position, 2 minus 1 is 1. If it was the third position, then 3 minus 1 is 2, which is the third position here. Okay, I hope this makes sense. Position or item is always whatever the number they give you, just subtract 1 from it to get the index and use that index in your code. So here, for example, if I write marks 3, this will give me the fourth item here, which is 100. Okay, I hope that is clear. This is important because some of your questions will use, but if the question uses the word index, you will use that number normally. So if the question says print the number at index 2, then you will use marks 2 because they've used the word index. Index is the actual numbering, but position or item is basically whenever you get the word position or item, you will just subtract 1 from that number and then use that number in the subscript. Okay, now we have this array. Okay, and now I've told you that, I mean, so far I've given you examples of double array. You can use any data type. You can even use string array. Let's say days is equal to Monday, Tuesday. I could have used a character array, but anyway, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and then Sunday. Okay, so now you have this array, and again we know that it is stored in this format. There's a huge container, there's a name given to this container, and then it is broken down into different sections. So Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Oh, we didn't need this, sorry. Okay. So here, what if I want to print all the values that are stored in the array? For that, we're going to use loops. Okay, anytime you want to print the array or search the array or go or look through the array, you're supposed to use a loop. Or even when you want to add all the elements together in an array, you're supposed to use a loop. So if you remember, the for loop is usually what we use with arrays. For int index is equal to 0. So basically the index is starting at this point. Index should be less than days dot length. Dot length will return the length of the array with human count. So if the last index is 6, the length will return 7 plus 1. because it's counting from 1. So you start your index at 0. This is where the index is starting. You end it less than 7. So the last number would be 6. And then increase the index every single time. Okay. Now, if I print out system dot out dot print ln, I can print, if you remember how we access the arrays, I said you're supposed to use the name of the array along with the subscript. So the subscript in this case will be index. And what will happen is when this code runs, it will create a variable index. So index will be 0 initially. Okay. And then it will check, is index right now, which is 0, is it less than 7? It is less than 7. So print days, go to the array days and get the value at index 0, because then the value of index currently is 0. The value here is m, so it will print m for you. Then it will go back, it will increase the, so from here it will go back to the increment, it will increase the index by 1. So now the value of index becomes 1, right? Now, is 1 less than or less than 7? Yes, it is less than 7. So get the value that is stored at 1, and at 1 there is t. I think let's change the color. Okay, at 1 you have t. Okay, again after here it will go back to increment. Now your index value, which was previously 1, now it's changed to 2. So which means in the index variable the value is now 2. Is 2 less than 7? Yes. So print whatever is in the index 2 of array days. In index 2 array days we have Wednesday, or W. And then go back again, change it to 3. Is 3 less than 7? It is. So print whatever you have in index 3. In index 3 we have R, or Thursday, so that will be printed. We'll go back again, change it to 4. Is 4 less than 7? It is. So whatever is in 4, that is printed out. And in 4 we have Friday, so that gets printed. Again, go back, change 4 to 5. Is 5 less than 7? It is. In 5 we have S, which is Saturday, so that gets printed here. And then it goes back, changes 5 to 6. Is 6 less than 7? It is. So again, print U, which is for Sunday. Finally, it will change index to 7. Now 7 is not less than 7. 7 is actually equal to 7. So at that point it will stop the loop. It will not loop again. One thing to keep in mind, this condition will always stay the same. You will never write it as index less than or equal to your array dot length, because in that case you will have, so if this was the condition that I wrote, I don't have anything at the 7th index, right? So in that, just to avoid that index out of bound problem, we don't keep equal to for checking the length of the array. So index should always be less than the length. I mean, this can change to this can change according to your situation or according to your problem, but you will never keep it equal to the length. Okay, it will always be less than the length. This is how you would loop through the array. So now, for example, one last example and then I can end this. If I had, let's say, an array, string array of direction, okay, and then it had north, south, east, west. Again, if I want to print this array the same way, you have to start from 0, because this is at 0 position, this is at 1, 2, and 3. So 0 index should be less than direction dot length plus plus index. Okay, and whatever you want to do can be done here. You can add if conditions, you can whatever you want, you can change whatever you want to do can be done here. Now one more thing that I want you to know is, for example, let's say I want to create, let's say I create this array here, string direction is equal to new, sorry, string array direction new string 4, string array of 4 of size 4. Now in this case, if you remember, this creates an empty array. So basically in the memory it's going to look something like this: 0, 1, 2, 3, and this is called direction. Now it's empty. If you try to access an empty array, it's going to give you an error because it doesn't have a value and you're trying to print the value, or you're trying to use that value in a calculation. It's going to be incorrect. It's going to give you an error. So one way of adding values to the array is that you can again use the subscript. You can access the array. So the name of the array, direction, subscript, let's say 0, north. What this statement is going to do, it's going to take this north value and it's going to put it in the 0 index of the direction array, which is this here. So this value will be added here in this index. If I have direction 1 south, that does the same thing. It goes to the first index and it stores the value there. If I write direction 2, it will take the value west and it will store it at the place 2. And the last one here in this case, direction 3, east, will be stored in the third position. If you try to do direction 4, that's wrong, because you only created size of 4, and the index 4 basically is the fifth element. You don't have a fifth element, so that will be wrong. Now if you have the array and the subscript on the left side of equal to, so for example here I have equal to and I have written direction let's say 2 is equal to, I want to change it to, let's say, northeast, for example. So whatever was stored here previously, here it was west, east, and south, right? Now whatever was stored in the index 2 will be replaced with whatever you're assigning here. So north, east will be now stored in that position. Now what I'm trying to say is, when you have the array and the subscript on the left side of equal to, so this is equal to, right? And you have the array and the subscript on the left side. In this case, you're either adding to the array or updating the array. In this case, I was updating. In this case, I was adding because it was empty before. But if you have the array and the subscript on the right side of equal to, meaning something like this, string test is equal to direction 0, that means, I mean here you have, I've used the array and the subscript on the right side of equal to. That means you're accessing the value. You're not changing or updating or adding nothing. You're only accessing the value. So what happens is the system will go to the zero index of direction, which is this part here, and whatever the value is, it will be stored in this string test. So this string test will have now north stored in it. Okay, so far this is the concept you should be familiar with. You need to practice how to create arrays. How do you create an empty array? How do you create an array with data in it or values in it? How do you add values to an array? How do you update values to an array, in an array? And how do you print values from an array? I've shown you how we print using a for loop. I've shown you how we change or add values, or how we access the values. Now it's your turn to basically practice this and try to be familiar with the concept, because from now on arrays is the biggest part of your of the course. So if you understand this very well, you'll do very well in the final exam, inshallah. So yeah, try to practice this. I will be uploading the video for lab 6A as well, but for now just try to understand this and try to practice the questions in the lab plus in the self-evaluation quiz. Okay, so that's it. I hope this was helpful, and yeah, all the very best. See you next time.